On the bench today, I've got something very special, a Fluke Enterprise LANMeter network tester. It's a 686 and it can do 10100 Ethernet network testing and token ring. And it's absolutely huge. Here is my cell phone for reference, and my cell phone's not all that small. I wonder if there's something funnier we can use for a size comparison here. Here it is next to a ZIP 100 disk. This thing is roughly 2 by 3 ZIP 100 disks. What is that? 6 square zips. This is a enterprise grade piece of networking equipment. The best I can tell, it came out around 1998, and the base model would have set you back about $13,000 retail. As far as I can tell, this thing can do anything. It can push traffic onto the network, it can monitor network utilization, it can tell you errors. So in the token ring world, it'll tell you if you're having beaconing or ring errors. In the Ethernet world, frame error, collision, jabber. It'll tell you which node on the network is using the most bandwidth, so you can go into that cubicle and shut them down. This thing is pretty involved. Luckily, I have the manual. I actually got the full carrying case and everything. I'll show you all that. But just to get you excited, let's get this thing doing something I actually do understand, which is a basic cable test. I really don't know how I'm going to be able to film this thing. I have a lot of glare issues. Let's turn it on. Maybe this top-down angle is going to work. So, it's got this backlit screen. You probably can't hear it, but it makes this whine, I think, to actually power that screen. And we're going to do a good old-fashioned cable test. So check this out. Got like a 1-foot cable. I'm going to put it in this jack here, and we're going to do a cable scan. It's got a bunch of relays inside that click and clack. It's pretty cool. And check it out. It knows the cable length is 1 foot. It uses like impedance and science to do this. This is like a 6.5 foot Ethernet cable. Let's run that scan again. Pretty darn close. 7 feet. Hopefully that got you excited. I was pretty pumped when I started doing that. That was the easiest thing I could figure out without reading the documentation. I've been reading the book, the good book. I'm really glad it came with this. Let me show you everything I've got, and then we'll get progressively more advanced as I actually myself learn how to use this thing. I really want to do traffic generation and try to like overwhelm a hub or something, or an existing network in the retro rack. We're going to figure out what this thing is all about. We will definitely get it on a token ring network. Let's get into it. I picked this thing up on eBay. In fact, IBM Museum put me on to the listing, so he's a bad influence. But I'm glad I've got it. Came with this nice carrying case, got a handle and everything. The manual's in there, we'll open that up. And then it came with the battery, and I haven't taken this out of the plastic that the seller put it in. Maybe it'll work, we'll see, I doubt it. And then this big beefy power supply so that you can run it without the battery, which is obviously pretty important here. None of that fits. This obviously goes in the unit, but the power supply doesn't fit in this case. It would be for, you'd have it charged and you would go out in the field. And it came with the manual in this front pocket. We will be referencing this a lot. It's actually a pretty good manual. I've read a pretty good chunk of it already. And when I got this, everything was in like individually wrapped plastic bags, and I thought, oh, well, that's kind of a nice way to ship this. And then I started opening them up, and smelled a lot like cigarettes, and so I let these air out for a while, and now they don't smell at all, which is great. But anyway, yeah, some good old-fashioned 1999 network engineer had this in the back of his rig, smoking Marb Reds. So got zippers here. This whole flap comes down, and it just barely fits in this thing. Nice Velcro strap to keep it in there. And yeah, it's big, which is why it has this nice stand so that you can actually use it. And then I did get one more accessory. This is called a wire map dongle. You can see that right there. It's labeled 0. I think you could have multiple running while you're testing and trying to find which wire goes where, I think. And it's this end of the plug, because I think you'd go into an office or a cubicle or something, plug this in, and you're trying to figure out which wire back in the data closet goes to here. Then you plug the far end over here, and there's a wire map cable test feature that we'll try out later to find where that thing's going. Of course, I just unwrapped this without the camera running, but I do appreciate how well the eBay seller had everything packaged up and safe. It is a Fluke 10.8 volt, 1800 milliamp nickel cadmium battery. You never know, it might work. No weird bulging or anything going on. And I believe there's something funny to worry about here. The seller actually messaged me and warned me that I should be very careful taking this tape off. I'll show you in a second. That little plug is how Fluke decided to key this connector. It can go in both ways on the device, and if you put it in the wrong way, you're going to have a bad time, and that stops you from doing that, and I think it can just fall out. So the seller was really careful to have that wrapped up, which kind of implies to me the seller maybe used this thing back in the day, I don't know. On the back, you lift the stand up, and I think these 2 screws are going to uncover the battery door. I don't know how much this is even worth bothering to do, but we'll plug it in and see if it charges while we're experimenting here. That actually takes the whole assembly off with the hinge, and it's just sitting in there on guides now. This thing is super clean, and obviously it was well taken care of. I guess I would as well for 13 grand. And then way down in there on the pin header, one of the pins is missing, and that is where the key is supposed to go. And if this little tab thing wasn't in there, I could just put it in whatever way I wanted. So I guess, you know, if it works, it works. All right, let's see what this thing thinks about that battery. It does a pretty cool self-test. And this utilization, all these LEDs start blinking. Bunch of clicks. Well, it didn't do it that time. Let's see if we can learn anything about what it thinks about that battery. Let's run a self-test. LANMeter self-test. Yes. Gotta press enter twice. There it goes. It turned the backlight off. Hopefully that's part of the self-test. Not really sure if I was supposed to have cables plugged in or whatever. It's off doing a bunch of stuff. It says it's doing a token ring lobe test. It's passing all its tests. It's pretty involved. This is like a couple minutes later, and it's still going at it. All tests passed. Took 2 minutes and 27 seconds. I'm really hoping my backlight comes back. Yes, it did. Okay, good. We're going to start simple. So it says it can do a hub auto test, and it's got this diagram where I'm just going to plug this thing right into a hub and then run that, see what happens. I'm going to go find a hub. I have found a hub. We're going to use this Intel Express 220T. I know this is a working, fully functional hub, and I was actually reading the documentation, pretty rare for me, and the hub auto test is essentially going to verify that a hub can correctly send and receive traffic. It does a bunch of other stuff, link pulse state, transmit polarity from the hub, receive signal level. Hopefully, it says sometimes it won't run all these tests, I guess. Ooh, interesting. It's saying it'll do pings or ARPs for some of the devices found on the hub. So we might need to plug a device into this and run it later. Let's just do it without anything in there for now. Let's get this thing plugged in. It's not the quietest thing in the world, as I recall. Probably could have had some better options here. Get a nice light show, though. And just like that, it's up. Of course, we'll get the other end going in right here. This video is going to be amateur hour trying to show you the screen on this thing. Nick, hub tests, hub auto test. It's running. It's doing stuff. Seeing no lights or anything interesting on the hub. Of course, nothing going on over here. There's no other devices. It can't test receive level probably because I don't have a device on the hub. This is going to be pretty unexciting. So link pulse normal. Transaction sense normal, 0 protocols. So it will actually scan network activity and see which protocols are running on the network in question. Okay. We need a device. They kind of look good next to each other. Got this Windows 7 machine hooked up to the hub, and it's not really doing anything. It's just trying to do DHCP and stuff. Let's run the test again and see if this thing, its behavior changes at all. I think these ARP requests coming in are actually from the test running. It says gratuitous ARP for 199.5.2021. Yeah, obviously, I didn't notice this until just now. It's coming from the Fluke. That was exceedingly uninteresting. No behavior change here. Can't measure RX level, doesn't see any protocols. What does zoom in do? No frames received from the hub. This hub is on my home network now, as you can see right here. Lots of stuff happening. All the activity from that pretty busy network flowing in on Wireshark. The broadcast stuff anyway. Oh yeah, it's seeing all sorts of stuff now. 4 protocols. I think it saw like something like 200 frames. Normal RX level it can detect now. It knows that TCP/IP is happening apparently. And I think if we zoom in, saw 182 frames. It saw 4 protocols. Interesting. Okay, well that was a little cooler. Let's get this Fluke and Windows 7 laptop off my home network. I'll come up with a more sophisticated setup as we progress here, I think. This thing had been charging for about an hour as I've been messing around so far, and of course, this battery is totally dead and doesn't work. And I noticed something as I was editing the footage I've filmed so far, there is some corrosion down there, some green stuff on those pins, and a little bit of it inside those, so this isn't going back in. I will eventually have to get in there and neutralize that, but it doesn't look widespread or anything. I think it was literally coming from this connector, so I think we're okay, but yeah, this guy is getting retired officially. And because I bet you're just dying to know, there's a trick to putting this back on. It's got this little edge, so you want to lift it up like that, and then it sets completely flush, and then you deal with this annoying thing flapping while you put the screws back in. I don't really have a plan here. All I know is the testing must continue. That would have been cool if I had thought this out and planned each test and made like a portal test chamber style badge for each test we're about to do, but oh well. I have built a testing apparatus so we can put an RJ45 cable in each side. Right now it is correctly wired, just passing them through as if it was just a cable, right? But then I can take these wires and swap them around and see if the detector will notice, and these colors don't matter at all. Don't worry about that. I was just using whatever wires I had. The only other tester I've used before is something like this. This is a Klein Tools RJ45 and RJ1112 tester, and it's got a dongle, and you put one end on one end of the cable you care about. Whoops. These are a little sketchy. We'll put another cable in here. You plug it in, and then that means it passed. So it's happy with that cable. If something's wrong, it'll complain. And the best you get is that there's a miswire or it's totally open. Let's simulate that to show you what this is all about. So I'm going to pull this, and I'm going to purposefully swap two wires around into the wrong position for an RJ45 Ethernet cable. And we'll get that back in there. And now we run our test, and it says, yeah, miswire. Something's wrong with this cable, not going to work. But that's kind of all you get. Check out what the Fluke can do. Very similar idea. Mine came with one of these Fluke wire map dongles. And so we're just going to pop that on the other end here. And if we come in here to cable test, we can run a wire map and press enter, clicking and clacking away. Just a few seconds later, it's done. Miswires found, and it tells you exactly which wires. So it knows I swapped around pins 1 and 2 on those jacks. So you can see you've got what it found. Found pin 2, expected 1. Found pin 1, expected 2. Really cool. Just for completeness, I'll put this back into the right state, and then we'll see what a successful test looks like, hopefully. Okay. And it says we're good. Cable wiring meets specification. So there we go. A few more tests down. Well, let's do some more network stuff. I've got the retro rack fired up in the other room, and it is one 10.0.0.0 network with a bunch of devices, some Cisco switches, a Cisco router, and actually there's 2 routers in the mix, and so it'll be really interesting to see what this thing can find. This thing is plugged into the retro rack network. Let's start with a simple cable scan, see what it thinks. Suspected cable problem. It says it knows the cable is connected to a hub or NIC, but pairs 1, 2, and 3, 6 are too short to make valid impedance measurement. Interesting. It's possible that there might be roughly 60 feet of cable, even though the room's not 60 feet away. Okay, that's fine. So I want to go to network monitor. That's what I'm most curious about. Presumably, it's just going to listen to anything it can find on the network and give us some stats. So I'm going to press enter, and it's saying it's going to log stuff. That's fine. Opening to net, it says. Not a lot going on that network. I would have thought it would at least see the routers chatting back and forth with each other. We're going to need to generate some traffic. Actually, speaking of generation, this is what I was most curious about. Traffic generation. I think it just blasts a bunch of large frames or something on the network. The problem is I'm going to need to like go onto those Cisco units and see if I can actually determine if something's happening. One problem is it's not on the right subnet. Sorry, you're learning with me live here. Let's go over to TCP/IP, and yeah, this thing is not on the same subnet as my 10.0.0.0 network. So let's see if we can do IP autoconfig, use DHCP. Yes, I want this thing to ask for an IP for my network, and it was assigned an IP. That is perfect. There is no DNS server. Let's save that. Network monitor, let's just see if we can get more stats. Nothing. I need to think about how to generate traffic. Another cool thing is you could have different packages that you would pay for. So I think I saw in an article The Switch Wizard and Wide Area Wizard packages were $1,000 each. And mine, I'm hoping, because it's telling me right here, seems to have them. And one of the features, I believe, is this like segment discovery stuff. It's going to try to find stuff on the network, switches and routers and everything. So we're going to run that. It found at least one switch. It found some items on the network. I wonder if I'm going to need to like go turn on SNMP on all my Cisco stuff so this thing can reach out and maybe try to find them. Letting it run, I think it just kind of goes off and runs as long as it can. Yeah, it found all sorts of stuff. Found this LAN meter. It's finding some Cisco stuff, but it doesn't understand this router. That's a VXR router, or at least it's not presenting it as anything particularly interesting. Yeah, it's finding all sorts of people talking on the network. I'm going to go do some reading, see if we can't do something a little more interesting with the traffic generation or the monitoring. Just for comparison, I plug this into my home network and we get very low utilization. Obviously, I'm not really sure how it's measuring that. No collisions, no errors. So that's about the same as the retro rack, but we see a lot of broadcast traffic, or more broadcast traffic, of course, than the retro rack, because there's a lot more items on my home network. And as far as, utilization and collisions and errors, I mean, these are switches. And even the stuff in the retro rack could run circles around anything this would have been testing in 1998, even though that stuff's pretty old as well. So yeah, maybe this isn't all that surprising. Pretty cool to see though. What we really ought to do is get this thing on a hub and produce a bunch of traffic somehow. And then I think we might start seeing collisions. So what we'll do is we'll set up a more small scale experiment with a really crappy hub down here and see what we can get. But let's go into setup utils before we do that. Hopefully I'm allowed to run this web agent. Oh yeah. The web agent allows access to this LAN meter via an HTTP browser. And you know I like that. So let's run. Yeah, so we should be able to hit this thing's IP address, which is 10.0.102 on the retro rack. I don't think it's actually started yet. It was making sure that there wasn't a duplicate IP. That was interesting. We'll listen until a tester utility needs to blah, blah, blah. Okay, start agent. Maybe it's running. I think it is listening. Okay, let's go check this out. This is a Windows XP VM, and it's always running in my Proxmox instance. And in some video, I had installed this ancient Modularity Cafe Cisco Systems screensaver, and it cracks me up every time I see it. And I never expect it. I'm like, what's going on with this thing? Anyway, no big deal. Let's see. I don't know if that thing's going to respond to ping, but I think it was 102. No, but hopefully we can hit it with HTTP. Even this thing is way too new for 1998, so we'll see how this goes. HTTP 102 on port 80. Let's see if that thing's going to respond to us. Kind of don't like that I can't ping it, but maybe that's fine. I know why I can't ping it. It's still plugged into my home network. 1 second. I'm not so sure it's going to like this interface going down, so I'm going to stop the agent. It stopped. This was my home network. This is the retro rack. Okay, interface is up. Let's start the agent again. Listening. Let's try that again. This is the iOS CLI of the retro rack router. Okay. Oh, we got some pings. Okay, there's hope. Let's hit this again. Oh, baby. Look at this. The Fluke logo. This thing has an image baked into its firmware to serve us. This is what it looks like. I didn't realize my head was covering the logo that entire time. Reports and graphs. Nothing. Access the current LAN meter display? No way. No way. Java, yes. Oh, I saw some screenshots of this. This is better than I could have ever imagined. Can I click? I don't want to stop the agent. Agent maintains status on exit. Oh, I'm going to go press exit on the device. The agent should be running in the background, and then we'll refresh this screen. Just press exit. Let's refresh. Yes, you can control. Wow. How did they do this? So can I click this stuff? Nope. You're probably supposed to be able to click this stuff. What's a get PCX? Oh, some file. I don't care about that. Can I zoom in? Oh, baby. This might be a new Club Retro sticker. The Enterprise LANMeter. Anyway, I would think you should probably be able to click the stuff. I suppose I could read the manual. Wow, this is so cool. I guess we can look at the data logs that I just tracked. This thing almost knows the correct date and time. And someone last took some Ethernet samples in 2007. Let's take a look at that. Wow, this is cool to see a log that's almost 20 years old. Awesome. I can't get over being able to see this display. I don't know why you would want to without being able to click. Let's find out. I was reading, and you aren't able actually to interact with the display. You can just view it. Totally overbuilt. So I think the main goal of the web server is to be able to download logs and things like that. My best guess is that you would set this thing up, I don't know, in a different building or something, or way down in a basement in a data set, you know, in your data closet, and you would put it on a screen you care about. And for some reason, you need to go somewhere else with a laptop or another workstation, and you want to be able to see this stuff while you're messing around somewhere else remote from the LAN meter. I don't know if you used these back in the day, let me know. That was interesting. That's a Java applet. Wonder if they're running Java behind the scenes on this thing. I kind of doubt it, but it was pretty hot back then. For my next trick, we're going to see if we can beat this Cisco HUB up a little bit. It is a Fast Hub 316T, I think, and it's era appropriate. It was built June 6th, 1998. And it's also really weird for a hub. It's modular. This whole tray comes out. I can't remember the company. I think Cisco acquired the guys that were making these in the mid 90s or something like that. But it's also managed. So you can get on the serial console and actually see what this thing's up to. And I think that's why it might be interesting. As I recall, it'll give you port and error statistics and things like that. So let's get that hooked up. Having trouble finding the right adapters. This might work. We'll see. I'll get this on my modern machine here. It's booting up. Hopefully you can see those lights. It's a pleasant fan, but it's a little on the louder side for what it is. On the serial console, and I see something. I'm going to go review my notes or my footage the last time I booted this up. This is either actually its messages it spits out, or I've got my serial settings all wrong. Found the adapters I was looking for, and we're back in action. Okay. I want to do like unit statistics report. Isn't this weird to see all this for a hub? The question is this going to sit here and refresh? But I think this will be good enough. I'm hoping that the traffic test tool can generate like big frames or something. I don't really know. Got the Windows laptop connected to the hub back in the mix here. And yeah, this screen is actually dynamically refreshing all these stats. I don't have to keep refreshing or whatever. So the Fluke is hooked up, and I think what we're going to do is just generate traffic and simply see if we can see that reflected on the Fast Hub's management interface, spitting out statistics. We'll go over to Network Monitor, Traffic Gen. I'm pressing Enter, and it should start generating traffic. Oh yeah, look at total good octets and frames going up. It's definitely doing something. Menu to configure. So it's sending 500 frames a second, and they're not very big. I want to do something weird and like really confuse this thing. 8,000. Wow, 5244. Okay, let's do that. I was trying to give it like a totally bogus frame size, but let's do that. I don't know. Let's send 5,000 frames per second. Will it let me? It will. Okay. Now we're going to generate the traffic. Oh yeah, check that out. Frames too long errors. Oh man. And if I scoot you down, this thing is showing utilization, I think, of the network it's plugged into. Not really sure how it does that. And we've got frame errors all over the place it's detecting because it's generating them. And of course, this thing is real busy. Look at those activity lights going. Here's the final setup. The retro rack is now connected to this hub. And for once in my life, I remembered ahead of time that you need a crossover cable to put a hub into a switch. This Windows 7 laptop is running a continuous iPerf test, and so basically it's attempting to download something. I think I have it in download mode, though it doesn't really matter, from a server on the RetroRack network, and we're getting about 7 to 8 megabytes per second. That's just continuously going. And by continuously, I mean after a few seconds, the socket totally explodes and the test stops. But check out the collision light in the activity lights when I start that test back up again. Just the iPerf test is destroying the network. I'm being a little grandiose, but tons of collisions. And the Fluke just simply plugged in, no testing or anything going on, notices that. It sees collision errors. It's seeing pretty high network utilization. The test will run about, I don't know, 40 seconds. I didn't really time it before it fails. I don't know who's at fault here, but the plan is I'm going to kick off that test. I'm going to start generating traffic and just see if the traffic generation influences it. I don't know why I'm so curious about this. That's what we're going to try. This hub might be a little too beefy to even be phased by this, but we'll see. iPerf is running. We are going to kick off some traffic generation. Oh yeah. This thing thinks things are maxed out. Yes, the scientific method. Look, we have dropped to 1 megabyte per second. We were getting near full 10, average of 7 to 8 or something. So yeah, that traffic generation is banging the hell out of this hub. She's not having a good time. This is why switches took over and then Ethernet was able to progress. What's happening here is all the traffic coming in from the traffic generator is being blasted out to every port that's connected. Yeah, the test just stopped, obviously. Basically, you can cause collisions where 2 or more devices are trying to talk into the ether at the same time, and they have to back off with little timeouts and try to avoid colliding at the same time. Switches essentially solve that problem. A bunch of other very sophisticated techniques as well, but yeah, look how easy it was to just kind of mess this thing up. So if I've given you PTSD from your network engineering days in the early 2000s, you're welcome. Here's a VM running the iPerf server on the RetroRack network, and eventually it just fails out with bad file descriptor, which I think is implying that the TCP IP connection is being severed, perhaps by the hub, I don't know. And now the moment that tens of you have been waiting for. This thing can also test token ring networks. Token ring was a competitor to Ethernet, and very different. So this is a token ring MAU, or media access unit. That's why on the Fluke it says hub/MAU, in case you're in token ring test mode. I like to say this is like a hub, but that's kind of where the analogy stops. The only thing they have in common is they interconnect different devices. The network that runs over them is very different. Ethernet, everything is allowed to go out into the ether, hence those collisions I was talking about. There aren't collisions here. A special packet called a token is passed around amongst all the devices, and it forms a logical ring, and only one device is allowed to talk at a time, and you avoid the collision problem. And anyway, Ethernet 1. But I've got some token ring gear, and I pulled out a couple of these sweet cables. Connor donated these to me at VCF Midwest this year, and they came from an IBM office, which is exciting. So I've got the big, is it Type 1 IBM style connector there that clunks into the MAU, and then RJ45 on the other end. We'll put that in the Fluke. I think the deal here is I can press tab to switch to token ring mode, and it wants me to confirm. Yep, a bunch of clicks. Oh, it's restarting. Wow. Yep, we are in token ring mode. What kind of cable tests do we have? Let's start just by seeing what it does with a token ring when we do the cable scan. Token ring cable, I should say. Nothing on the other end. We're going to do cable scan. It thinks it's 10 feet. It might be. I don't know. Let's do the MAU auto test. No, I want to do a lobe test. In the token ring world, this cable connecting a device to a MAU or a cow, there's other stuff. It's called a lobe. So let's plug that in. Token ring networks of this era ran at 4 megabits per second or 16. They got faster later. And so it's going to test, apparently, if this lobe is capable of that. Starting with the 4 megabit per second test. That failed for some reason. That also failed. Okay. Plugged another one in, another known good token ring cable, just to see if it does something different. Maybe there needs to be a computer on the ring for it to actually accomplish this, I'm not sure. Ooh, this one's passing. 16 megabits passed too. I think we just used this Fluke for something actually useful. There's probably a problem with this cable. It is really angled. It was jammed into a rack or something. Really tight. So it's possible that's damage. Let's try the other one. This is exciting. I'm sure you'll agree. Yeah, let's see what this other one's about. These are very weird. I've never seen this exact style. They don't really want to go in the MAU very well. All right, let's run that again on the other cable. Running it on that one. Failed. Also failed. out of curiosity. Let's put it somewhere else. These can get in a state where you have to reset them. That's a whole thing. So it is possible that that MAU port is just messed up. Run the test again on a different MAU port. Failed again. It does not like these cables. Well, that actually saved me a lot of headache, because I would have never in a million years guessed it was the cables that were at fault. Or maybe these are slightly different than I think they are or something. I'm not sure. They could be wired for something else. Yeah, I don't know. Here's the good one. Token ring only requires 4 wires. I've got 4 in there, and this one is using all 8. So this might be for something slightly different, maybe a different style of token ring, or it could have been used. I think you could use these for phone. You could obviously travel phone lines over these if you wanted. Maybe it's just wired for something specific, or the cables are actually broken. Okay, enough cable stuff. I know this one works. Let's perform what it's calling a MAU test. I'm going to go to MAU Autotest, and that is how we are connected. I'm going to say run. Don't really know what it's going to test. Okay, yeah, so a device, a lot of devices can detect the speed of the ring and choose whether they should run at 4 or 16. A ring can only run at one fixed speed. It's going to enter at 4. That is fine. It's actually doing the load tests we were just doing, apparently. These also have relays inside, and when something's entering the ring, you can hear them click, and I just heard this one click, so this is a really cool tool to have. So yeah, what it's saying is it was able to enter the ring. It was the only item on the ring, which is not very useful, but the MAU, at least this one MAU port, is operating properly. That is very cool. Let's get one more device on the ring. This is the ring, by the way. A real actual laptop that can connect, and then run some more tests. Got this ThinkPad running Windows 98, and I can hear this thing clicking. It is trying to enter the ring very early in startup. I think it did enter. I'm pretty sure this one's going to auto set it to 16. Maybe we can determine that with the Fluke. I don't know. But we now have a node that is on the ring. And I'm not going to lie, that was about the extent of my plan so far. Let's run the MAU test again to see if it sees someone else. We are not going to want that to enter the ring at the wrong speed, actually. Whoa. You can reset the MAU ports with this thing. Usually I have to buy this for like 180 bucks on eBay. I'm borrowing this from Doogie Labs at the moment. That is really cool. That made this thing worth buying just for that. Like I was saying, those MAU ports can get stuck and you got to reset them. That is really cool. Let's instead go to network monitor, ring stations. Now we're talking. Okay. So it's going to try to get in the ring. I think it's not warning me about 4 versus 16. So I think it's going to attempt to detect the ring status. This is cool. Yeah, that is so cool. It found the other machine on the ring. What about network stats? That broadcast was probably us. Beaconing, I think, is when you don't want that. It's bad. I think the ring is panicking and trying to find what is it called? The ring sort of Alexa machine as what is the name of that thing? The active monitor. One of the devices on the ring, they elect with some algorithm to decide one of them is the active monitor, and it is basically monitoring the health of the ring and taking action if something goes wrong. I knew this IBM token ring network architecture reference would come in handy. But I was talking about beaconing. A beacon frame is sent by an adapter when it detects something very wrong with the ring. Their example here is a broken cable. The ring needs to be complete, so you can't have a node that's misbehaving and breaking the traveling of the packets through the ring. And when an adapter is doing that at some interval, it's said to be beaconing. And yeah, it's bad news when that happens. This thing will actually detect beacons and start complaining to you. But yeah, back to talking about active monitors. And I was guessing this was the active monitor because it was the first thing on the ring. And if we look back at our node list, the other machine it found has AM in parentheses, which almost certainly stands for active monitor. So it's very interesting to actually understand pieces of what's going on in the token ring. It's actually very hard without, I think there's software you can run on the devices to learn this stuff because it's all just being transmitted over the network, right? I mean, obviously this thing's allowed to get in the ring and ask questions, but that is really cool. There's probably not a lot of errors. 1 token soft error and 1 burst, apparently. We're not going to learn much, but apparently we can generate traffic on the ring. Token rotation. Measures the time it takes a token to traverse the ring. Obviously, that's cooler than traffic generation. It's doing that. We've only got 2 stations on the ring, of course, but 16, what is that, microseconds? And it likes it, says it's good. That probably concludes our testing, but I'll tell you, Having done a lot of this token ring stuff from scratch myself, it is very cool to even know anything about what the ring is up to, because usually you don't. You're running blind and you're literally listening to these things click and clack to hope that your device has entered the ring or someone's causing problems on the ring. Like I was saying, it is awesome that that thing can reset ports. In fact, maybe we will do that now. Usually I was saying you use this tool. I'll show you what that ends up looking like. This thing just has a 9-volt battery inside of it, and you insert it. And now that port is reset. You probably heard that slight click of a relay. I think I've reset all these ports before. That is really cool. So let's reset one of these ports just for fun. I'm going to press enter now. Yep. Hopefully you heard that click. That's exactly what this tool would have done. And it says the MAU appears to reset correctly. I like it. This thing is amazing. Something interesting I found while researching this, at least to me anyway, is that Fluke was founded way back in 1948. I've always known about Fluke. I've always associated them with a high quality product in my mind, though I've never used any Fluke tooling. It's not really for a layman messing around in their home lab typically. And they're headquartered in Everett, Washington. And yeah, they've got a big corporate headquarters in Everett, Washington. They've got their own pond, apparently. This is interesting to me because I grew up in the Seattle area. I lived the first 30 years of my life in Seattle. And it's funny, you can show me a picture of anywhere in Western Washington that I've never even seen before. Like if you showed me this picture and said, where in the United States is this? I would immediately tell you it's in Washington State. I don't know. Just Washington just has a particular look about it. It basically looks like this. It's quite nice. And then right next door, here's the Fluke building and their nice little pond. Is the big ass Boeing Everett production facility where they used to make the 747s. I don't know why I think this is interesting. It's just funny that Fluke is right next to the massive Boeing campus. Anyway, oh, check it out. We got some planes right here. Oh yeah. Fresh ones. I just barely scratched the surface of what this thing is capable of, and I probably bungled a bunch of stuff along the way. It can do like NIC testing, so you can hook it up directly to a NIC in a computer, a network interface card, and see if that thing is behaving. You can put it in line between a hub or a MAU, plug it into here, and then plug it into the computer and monitor stuff that way. It's like capable of anything. And I was thinking about it. We solved a cable problem. I don't know what I did with those token ring cables around here somewhere. But I feel like I'm going to be able to retire from YouTube if I pull this thing out and actually successfully diagnose a networking problem with it. So hopefully that happens in the future. Don't forget to like and subscribe. But that's going to do it for this one. I was hesitant to buy this. I've always wanted one. And IBM Museum, thank you for pushing me over the edge and making me do that. I think I paid like 160 bucks shipped to my house for this, which is a little better than 13 grand in 1998. And again, when I'm talking retail prices, a lot of big companies that would have been buying these things, they're not necessarily paying 13 grand, but it would have been thousands and thousands of dollars to get one of these. So it's a pretty serious piece of kit, and I'm happy to have it. I think we'll be seeing it on the channel in the future. I hope you enjoyed following along. This is kind of weird. We just did a bunch of tests with a Fluke LANMeter. But if you like this sort of thing, I've got a Patreon where I post behind the scenes type footage, what I'm tinkering on, and occasionally early release of a video. But that's going to do it for this one. I hope you enjoyed this video, and I'll see you in the next one.